Welcome once again. This is a continuation of the 2023 November paper 1 O-level mathematics exam. So we are going to continue from number 10. A map is drawn to scale. A map is drawn to scale of 1 centimeter to 10 kilometers. A express the scale in the form 1:n. So it's drawn to scale of 1 centimeter to represent 10 kilometers. So we convert this 10 kilometers to centimeters. So it's 1 centimeter to represent 10 kilometers to meters is 10,000 meters. Then we convert this 10,000 meters to centimeters. So 1 centimeter, here we've multiplied by 1,000, since 1,000 meters is equal to 1 kilometer. So we multiply 10 kilometers by 10. Multiply 10 kilometers by 1,000 to get 10,000 meters. Then 1 centimeter represents, we are now converting 10,000 meters to centimeters. 1 meter is equal to 100 centimeters. So we multiply this by 100 to get 1 million centimeters. So we express it as the scale in the form 1:1 million. Right. So that's our number 10A. For 10B, find the actual distance represented by 2,7 centimeters on the map. So we are saying 1 centimeter represents 1 centimeter represents 1 million centimeters. So 2,7 centimeters will represent what? It will represent more. So it's simple proportion. So we are going to divide 2,7 over 1 multiplied by 1 million. So 2,7 multiplied by 1 million, we get 2,700,000. So 2,7 centimeters on the map represents 2,700,000 centimeters on actual ground. Moving on to number 10B, part 2. Calculate. We are required to find the area on the map that represents an actual area of 120 square kilometers. So we are saying 1 centimeter. We are given that 1 centimeter represents 10 kilometers. Right. So we are now calculating the area. We want to find what is being represented by 120 square kilometers. So to find that, we square this part, we square that other part. So 1 square centimeter represents 100 square kilometers. So if 1 square centimeter represents 100 square kilometers, what will be represented? What an area of 120 square kilometers will be represented by what? So it will be represented by more here. So 120 square kilometers will be represented by 120 over 100, that's square kilometers multiplied by 1 square centimeter. So this gives us 1,2 square centimeters. So 1,2 square centimeters will represent 120 square kilometers. Then number 11, A, B, C are points on level ground such that the bearing of A from C is 205. The bearing of A from C. So there is our our C. Bearing of A from C, this is north, is 205. So this is 90, 180, 205 will be found in this quadrant. So this is 270. So to find this angle, this is 205. To find this angle, we are going to subtract 270 degrees minus 205 degrees. So we get 65. So this angle is 65 degrees. And if this angle is 65 degrees, we said 270 degrees minus 205, we get 65. So this angle is 65 degrees. So if this angle is 65 degrees, we want to find this part. So this part is 90 degrees minus 65 degrees. We get 25 degrees. So this angle is 25 degrees. So if you add 180 degrees plus 25 degrees, we should get 205 degrees. Then, and the bearing of B from C is 347 degrees. The bearing of B from C, so yes, our starting point there is C. The bearing of B from C is 347. This is 90, 180, 270. So B is in this direction. That's where our P is. So to get this angle, we subtract 270 from 347. 270 minus, 347 minus 270. 7 minus 0, it's 7. 14 minus, it's 7. So it's 77 degrees. So our angle there is 77 degrees. Then to get this one, we subtract 77 from 90. So 90 degrees minus 77, we get 13 degrees. So this is 13 degrees. Right. So if we subtract 360, we subtract 347 degrees from 360, we should get 13 degrees there. That's another way to find this angle. So to calculate angle ACB, this is A, angle ACB, this is our C. We are going to add 77 degrees plus 65 degrees. 77 degrees plus 65 degrees. 7 plus 5 is 12. Then 7 plus 6 plus 1 is 14. So this is 142 degrees. Then find the bearing of C from B. Let me draw a clear diagram there. We have our C there. This is C and this is B. This is A and this is 65 degrees and this is 77 degrees. This is 25 degrees. And this is 13 degrees. So, and this is the north side. So to find the bearing of C from B, we are going to draw a compass there. So the bearing of C from B we want to find this angle. So to find this angle, we have a Z angle there. These are parallel lines. So we have a Z angle. So this angle 77 degrees is equal to this angle 77 degrees. So the bearing of C from B, we are going to add this 90 degrees plus 77 degrees. So 90 plus 77, we are going to get 167 degrees. So the bearing there is 167 degrees. Then we move on to number 12. So for our number 12, we've set build annotation there. It is given that universal set is equal to the set of 11 less than x less than 20. It should read the universal set is equal to the set of x such that 11 is less than x less than 20. And x is an integer. So we are saying x is a set of integers, but x is between 11 and 20, not including 11 and 20, with subsets a, b, and c such that a is equal to the set of x such that x is a prime number, b is equal to the set of x such that x is an odd number, and c is equal to the set of x such that x is a multiple of 3. So we are required to illustrate this information on a clearly labeled Venn diagram. So first we list our universal set, the elements of our universal set there. So universal set is equal to the set of 12, 13, 14, 15, 16, 17, 18, and 19. Then set A is equal to the set of prime numbers. So we write down our prime numbers from the universal set. So it's 13, 17, and 19. Then set B. Set B is equal to the set of x such that x is an odd number. So we are writing odd numbers 13, 15, 17, 19. Right. Prime numbers. Set A is equal to the set of prime numbers. Prime numbers are those numbers that have only two factors, 1 and itself. So 13 is only two factors, 1 and itself. 17, that's the same for 19. Then odd numbers are those numbers which, if we divide them with 2, we obtain a remainder of 1. So if we divide 13 by 2, we get 6 remainder 1. If we divide 15 by 2, we get 7 remainder 1. So these are odd numbers. Right, then we move on to C is equal to the set of x such that x is a multiple of 3. So multiples of 3, we have 12. Multiples of 3 are those numbers that can exactly be divisible by 3. So we have 12, we have 15, and 18. Right, we are done with listing the elements there. Then before we draw our Venn diagram, we find the intersection A, intersection B, intersection C. When drawing a Venn diagram, we have to start by entering the elements which are in the intersection of these three sets. So the intersection of A and B and C is it's an empty set. We don't have an element that is in all three sets. So the intersection there is an empty set. Then we move on to find A intersection B. The intersection of A and B, elements that are found in A and in B. They are both in A and B. So they are in both sets. So we have 13, 17, and 19. Then A intersection C. Right, A intersection C, we don't have an intersection there, so it's an empty set. Then B intersection C, we have 15. Right, so after that we can now draw our Venn diagram. So this is the universal set. Right, then we have set A, set B, and set C. A, B, and C. So we start with our intersection. A intersection B intersection C is an empty set. A intersection B. A intersection B, we have 13, 17, and 19. 13, 17, and 19. Then A intersection C, it's an empty set. A intersection C, it's an empty set. Then B intersection C, B intersection C, we have 15. Right, so we have written out 13, we've written out 15, 17, and 19. Then set A, we have 13 is there, 17, we've written it out, and 19. Then set B, we have 13, we've written it, 15 is there, 17 is there, and 19 is there. Then we move on to set C. We have 12, we write it there, 15 is there, and 18. Right, so 12, we are done with 12, we are done with 18. So 14 is not an element of all these three sets. So 14 is here. So that's our Venn diagram. Then we are required to list the elements of A. We've already listed the elements of A. So A is equal to the set of 13, 17, and 19. So our A is equal to 13, 17, and 19. And we now move on to C. Find the number of A intersection C. Right, number of A intersection C is 0. We do not have any element in this set. So A intersection C is equal to 0. Then in the diagram, number 13, in the diagram, A, B, C, A, C, A, B, C, A, C, D, A, C, D, and A, B, D are triangles such that BC is 8 centimeters, AC is 10, and CD is 9, and angle ABC is 90 degrees. Calculate the cosine of angle ACD, giving the answer is a decimal. So we know that these two angles are supplementary, and this is an obtuse angle. So the cosine of this angle, this is our ACD, the cosine of this angle is equal to negative cosine of this angle. Right, So first we find the cosine of ACB. So cos ACB is equal to, if we find the cosine of this angle, it will be equal to minus negative of the cosine of ACD. So the cosine of ACB, according to our acronym CHA, SHO, TAO, the cosine there is equal to adjacent of hypotenuse. So cos ACB is equal to adjacent over hypotenuse. So the adjacent there is 8 over hypotenuse is 10. Right, so that's our cos ACB. We can reduce this. Right, the question requires us to give our answer as a decimal. So 8 over 10 becomes 0.8. So cos ACB, we said that the cosine of angle ACB will be equal to the negative, the cosine of ACB is equal to, we want to find the cosine of ACD. So we now have cosine of ACB being equal to 0.8. So 0.8 will be equal to negative cos ACD. So to find the cosine of ACD, we are going to divide by -1 by -1. So cos ACD will be equal to negative 0.8. So that's our cosine of ACD. So it's negative 0.8. Then we move on to B. Calculate the area of triangle ACD. So to find the area of triangle ACD there, we first find the sine of angle ACD, right? The sine of this angle. So the sine of this angle is equal to the sine of this angle. So to find the sine of this, we now say sine ACB. So we are saying sine ACB is equal to sine ACD. Right, the sine of angle ACB is equal to the sine of angle ACD. Right, so the sine of this angle from CHA is equal to opposite over hypotenuse. So the opposite of this angle is unknown there. So we can use the Pythagoras theorem to find the opposite side. So by Pythagoras, AB squared plus 8 squared, AB squared plus 8 squared is equal to 10 squared. So AB squared is equal to 100 minus 64. AB squared is equal to 36. So the square root there, AB becomes 6. So AB is equal to 6. So the sine of this angle, since this side is 6, the sine of this angle is equal to 6 over 10. So sine ACD is equal to 6 over 10. So the area of that triangle, the area of this triangle is equal to half 10 times 9 sine area is equal to half times 10 times 9 sine ACD. But our sine ACD is 6 over 10, so it's 22 into 10, it's 5. So this becomes 5 by 9, 45 times 6 over 10. Then this 10, so 5 into 10 is 2, 5 into 45 it's 9, then 2 into 2, 1, 2 into 6 is 3, 9 times 3, 27. So it's equal to 27 square centimeters. Right. Then we move on to number 14. Given the formula 1 over C is equal to square root of B minus A. Find C if A is equal to that and B is that. 1 over C is equal to the square root of B minus A. So to find C, we now substitute A and B with those values. So 1 over C is equal to the square root of our B is 21 minus A is negative 4. So 1 over C is equal to square root of 21 plus 4. This becomes a plus, so 21 plus 4 is 25. 1 over C is equal to square root of 25 is 5. Then we cross multiply the 1 times 1, we have 1. Then C times 5 is equal to 5C. 1 times 1 is 1. C times 5 is 5C. So it becomes 1 is equal to 5C. Then to remain with C, this side we divide both sides by 5. So C is equal to 1 over 5. Right. Make A the subject of the formula. We have our formula 1 over C is equal to the square root of B minus A. So first of all, we remove that square root. So to remove the square root, we square both sides. Right. So we now have 1 over C squared. 1 squared is 1. C squared is C squared. Is equal to B minus A. Then this comes this side. So A becomes B and this comes this side. B minus 1 over C squared. So A is equal to B minus 1 over C squared. Right. Then we move on to number 15. Solve the following equations. 5m minus what is equal to 0. Either this bracket, for this product to be equal to 0, is either this is 0 and we multiply this 0 by this to get 0, or this is 0 and we multiply it by this to get 0. So we say it's either 5m minus 3 is equal to 0 or 2m plus 1 is equal to 0. So we solve this part. 5m is equal to 3. Divide both sides by 5. So m is equal to 3 over 5. Or we solve this part. 2m, this becomes minus 1. Divide both sides by 2. So m is equal to negative half. So m is equal to 3 over 5 or negative half. Then to solve this, first we clear fractions there. So to clear fractions, we have one fraction on this side, one fraction on the other. So this is the easier way is to cross multiply. 2 multiplies n plus 2 is equal to 3 multiplying 3n minus 1. Then we multiply 2 by n, 2n, 2 by is plus 4 is equal to 3 by 3n, 9n, 3 by negative 1 is negative 3. Then we group like terms there. This comes this side in this. So it's 4, this becomes plus 3 is equal to 9n, this becomes minus 2n. So 4 plus 3, 7 is equal to 9n minus 2n, it's 7n. Divide both sides by 7. We remain with n is equal to 1. So n is equal to 1. Right. So that's our number 15. For today, we are going to end here. We will resume our revision in our next video. Thank you for watching this far. Remember to subscribe, like and share my videos. Thank you very much.